Welcome to this special newsroom-style briefing of our deep dive. Today, we're opening up a highly focused window looking exclusively at Google AI updates published between February 22nd and February 28th, 2026.
Right.
We've got a stack of primary sources here, release notes, technical blogs, developer documentation, and we're going to unpack exactly what they mean for you and your daily workflow.
And our mission for this deep dive is to track a massive, definitive pivot that's happening right now in the tech landscape. We're moving away from passive generative models.
Yeah, the time that just sit there waiting for you to type a prompt.
Exactly. We're shifting toward active autonomous agentic systems. So we want to invite you to step into the newsroom with us. We're going to look at exactly how this week's updates are going to impact your tech stack, your development cycles, and frankly, your security protocols moving forward.
I love that framing. You know, we're
Yeah.
moving from tools that just talk to tools that actually do things. And looking through the Google DeepMind release notes from February 26th and 28th, that shift is crystal clear with their massive dual launch. They rolled out Gemini 3.1 Pro alongside a model with a truly fantastic name, Nano Banana 2.
It is quite the name.
It really is.
Nano Banana 2 is actually the internal and now public moniker for the Gemini 3.1 Flash image model. So Google officially launched Gemini 3.1 Pro to handle advanced complex reasoning,
Right.
but they released Nano Banana 2 right alongside it, specifically built for high-speed, photorealistic image generation and editing. And the technical significance here is profound.
How so?
Well, we're looking at a leap from standard prompt-based pixel generation to what they're calling thinking models for visual assets.
Wait, what does a thinking image model actually mean for a designer or, say, a developer listening right now? I mean, how is that different from what we had 6 months ago?
It really comes down to context and consistency. Nano Banana 2 effectively democratizes enterprise-grade visual pipelines. You can now maintain strict subject consistency for up to 5 separate characters and 14 distinct objects within a single workflow.
That's huge.
It is. Previously, if you asked a model to generate the same character in different poses, their jacket might change color or, I don't know, their haircut would slightly shift. Now the model actually thinks about object permanence. Plus, it utilizes real-time Google search grounding.
That search grounding is fascinating. So if I ask it to generate an image of a news anchor standing in front of a live weather map of the East Coast, it's not just hallucinating random clouds.
Yeah, not at all.
It's pulling accurate current meteorological data to render that specific map.
Exactly right. And it combines that pro-level visual accuracy with flash tier generation speed. It also introduces new native resolution tiers, starting at a lightning-fast 512 pixels, so half K, all the way up to full 4K resolution without needing a secondary upscaler.
And reading through the Google Cloud blog, the aspect ratios are really what caught my eye. They're supporting extreme aspect ratios natively now, like 1.8 and 8.1.
Which is notoriously difficult for AI.
Right. If you've ever tried to generate a tall, scrolling web banner or a super ultra-wide billboard asset, you know, AI usually generates a square that you then have to crop.
Yeah, which totally ruins the composition.
Exactly. Native support means it conceptualizes that extreme canvas perfectly from the very first pixel.
Which brings us perfectly to the underlying documentation that makes this usable for engineers. On February 26th, Google AI for Developers published the official model card for this newly designated Gemini 3.1 Flash Image Preview model.
I always appreciate a good model card. It's essentially the instruction manual and the spec sheet combined, but the numbers on this model card are staggering. We're looking at output limits of 4K tokens for images, up to 64K tokens for text, and a massive 1 million token input window.
Yeah, the scale's incredible.
Let me ask you, though, why do I need a 1 million token input window for an image generation model? Am I really writing a novel just to get a picture?
Well, you aren't writing a novel, but you might be uploading one. Having a 1 million token window means you can feed the model vast amounts of organizational context before it generates anything.
Ah, okay.
Imagine uploading your company's entire 500-page brand guidelines, all your hex color palettes, previous marketing decks, specific font rules. You give the agent deep, robust context so it can autonomously generate a visual campaign that perfectly matches your corporate identity.
So it's not just a prompt anymore.
No, it acts as a stable, documented contract for developers building scalable visual pipelines.
That makes total sense. You're briefing the AI the exact same way you would brief a human design agency.
Exactly.
And speaking of giving AI a job to do, let's look at how this is hitting consumer hardware. At the Galaxy Unpacked event on February 25th, Google Android announced that the Gemini 3 series is bringing true Agentic AI to the Samsung Galaxy S26.
This is where we see the shift from passive to active in the palm of your hand. Google announced that the new Galaxy S26 will be able to execute complex, multi-step application workflows completely autonomously.
Wow.
And crucially, it does this in a secure virtual window on the device itself.
Let's break down what that actually looks like for you as a user. It's not like the old voice assistants where you say, open DoorDash, and it just pops the app open for you to do the work.
Right, it was just a shortcut.
Exactly. This is like handing your unlocked phone over to a highly competent personal assistant. You can say, order my usual weekly groceries from DoorDash, and the agent actually navigates the menus, adds the items to the cart, and places the order in the background. It transforms your smartphone from a passive operating system into an active operator.
Based on the details published on the Keyword Google's main blog, what's so compelling here is the user interface paradigm shift. The phone is no longer just a grid of apps that you tap. The phone is an agent that taps the apps for you. But building those reliable agents, that requires an entirely new approach to developer tooling.
It really does, because if my agent hallucinates while writing a poem, it's funny. But if my agent hallucinates while ordering groceries or accessing my bank app, it's a disaster.
The very expensive disaster.
Which explains the updates to the Agent Development Kit, or ADK, published on the Google developers blog between February 24th and 27th.
Yes. Google significantly expanded the open source ADK ecosystem with new third-party tools. But the most critical part of this announcement was their official advice to developers. You have to stop relying on vibe checks and move toward rigorous, continuous evaluation.
Okay, we definitely need to talk about the vibe check trap. In traditional software engineering, a unit test is deterministic. If you write a test that asserts 2 + 2 = 4, it will always equal 4. It never randomly drifts.
No, it doesn't.
But generative AI is probabilistic.
Precisely. A prompt that successfully pulls data from an API 99% of the time today might suddenly drop to a 92% reliability rate tomorrow. The model's internal weight distribution shifts slightly, or a minor temperature parameter introduces a totally new sequence of tokens.
So things just change under the hood.
Exactly. A vibe check is when a developer just eyeballs the output a few times, says, looks good to me, and pushes it to production. That is incredibly dangerous for enterprise deployment.
So how does continuous evaluation actually fix that?
Continuous evaluation integrates automated judging models to formally verify your agent's output using structured data. It constantly tests the agent against thousands of edge cases. Furthermore, Google introduced a new primitive called the McP toolset.
Repeat toolset.
Right. Think of McP toolset as a universal, highly secure adapter plug. But decoupling the core AI reasoning from the tool execution, you can seamlessly and safely connect your agents with external platforms like GitHub, Jira, and Stripe.
That separation of logic is brilliant. It ensures that when your agent connects to Stripe, it doesn't accidentally hallucinate a billing date. Or when it connects to Jira, it doesn't close the wrong bug ticket just because the language model had a slight probabilistic drift.
Exactly. It's about building production-ready reliability.
And that level of orchestration is now bleeding directly into creative workflows as well. On February 24th, Google Labs announced the launch of Producer AI alongside something called the Opal Agent Step.
Yes, Producer AI.
It integrates Lyria 3 generative music capabilities directly to users. But the Opal Agent Step is the real architectural breakthrough here.
Reading the keywords breakdown, Opal introduces a dynamic agent step that autonomously selects the right tools for whatever objective you set. It's the AI acting as a project manager.
Yeah. This signals Google's broader strategic move away from simply offering raw model endpoints. They're transitioning toward configurable multi-step systems. With Opal, you give it a high-level goal, say, create a promotional video for my new product. The agent step decides entirely on its own. First, I need to trigger Google Web Search to gather current market trends. Second, I need to use Gemini to write a script based on those trends. Finally, I need to pass that script to the VO video model to generate the footage.
And you never manually linked those APIs? The workflow orchestrated itself.
It's autonomy in action. But let's take a step back and look at the physical reality of this. If agents are suddenly doing all this invisible work in the background, searching, evaluating, triggering APIs, that requires a colossal amount of back-end horsepower.
It does.
A simple chat prompt is one server call. An agentic workflow might be 50 hidden server calls before you ever see a result.
Which perfectly explains the massive infrastructure announcements from Google Cloud on February 27th and 28th. They reached general availability for their Dataflow C4A ARM-based virtual machines, but more importantly, they previewed Ironwood.
Ironwood, that's their 7th generation tensor processing unit, or TPU. And looking at the Cloud Console release notes, it's heavily optimized specifically for inference-heavy workloads.
Yes.
Alphabet is backing this up with an estimated $175 billion to $185 billion infrastructure investment.
That number is not a typo.
It's hard to even wrap your head around that.
I know. But that massive capital expenditure guarantees the extreme power density and the specific price-to-performance ratios you are going to need to scale these demanding semi-autonomous operations later in 2026. Ironwood is the physical backbone built specifically to handle the massive, invisible inference load of agents constantly looping, planning, and executing tasks in the background.
But of course, with massive scale and hyper-fast deployment comes inevitable friction. The plumbing still matters, and sometimes the pipes burst.
Unfortunately, yes.
Looking at the Google Cloud Service Health dashboard between February 25th and 27th, we saw a stark reminder of what happens when things break.
We did. There was a 1 hour and 58-minute global outage for Vertex AI Gemini API endpoints. Users were getting hit with 429 and 503 errors.
Just a wall of air.
Basically, a 429 error means the system thinks you're making too many requests and rate limits you, while a 503 means the server is just completely unavailable. And at the exact same time, over on the AI Developers Forum, engineers were reporting extreme user interface freezing and restart to update loops in the anti-gravity developer environments, specifically versions 1.1, Heat 0.3, and up.
Let's unpack the Vertex AI outage first. What actually caused the endpoints to crash globally for nearly 2 hours?
Calmly analyzing the root cause, it wasn't actually a failure of the Gemini model itself. It was a safety filter configuration issue.
Oh, interesting.
The centralized middleware that checks prompts for safety violations essentially choked the endpoint. And this matters because it exposes the stability paradox of rapid AI deployment.
Yeah.
Centralized safety middleware carries significant cascading risks. If your safety filter goes down, it takes downstream enterprise tools like Dialogflow CX, which powers massive corporate customer service chatbots. Your entire agentic stack halts.
It's a complete domino effect. And what about the anti-gravity IDE freezing? Developers were basically trapped in a loop where their coding environment kept telling them to restart, but never actually updated.
That was a classic software engineering problem colliding with the hyperfast release cycle of AI tools. It was caused by a language server Windows lock in the background.
File locks.
Always. The aggressive auto-updater tried to overwrite system files that were actively being used by the AI code completion agent. It's like trying to change the tires on a car while you're still driving down the highway. It's a vital reminder that as we push frontier AI into production, the traditional rules of stable software deployment still absolutely apply.
And unfortunately, accidental outages aren't the only risks you have to worry about. As your systems gain autonomy, deliberate attacks become much more sophisticated. On February 28th, the Google Threat Intelligence Group published a major report identifying entirely new classes of AI-driven threats.
This is a sobering but necessary read on the Google Cloud blog. The report identified 3 major emerging attack vectors: model distillation, AI-integrated malware like HonestQ, and something they're calling agentic reconnaissance.
Agentic reconnaissance sounds like something out of a sci-fi novel. What exactly are threat actors doing here?
The report specifically called out APT31, which is a well-known advanced persistent threat group. Instead of having a human hacker manually poke at your network firewall looking for open ports, they're unleashing autonomous agents to probe your network at machine speed.
That's terrifying.
It really is. These agents can map vulnerabilities, test thousands of password permutations, and adapt their strategies on the fly without human intervention.
You essentially have to fight AI with AI at that point. Because your systems are transitioning from just generating text to actually taking operational actions, you have to completely redefine your security perimeter.
Yes.
The report heavily emphasizes using the Secure AI framework, or SIF.
Yeah, SAIS is crucial here,
Yeah.
and relying on strict provenance tools. They specifically mandate the use of Synthi watermarking and CTPA credentials.
Let's clarify C2PA for a second.
Sure. For those unfamiliar, C2PA acts like a digital, tamper-proof wax seal for media and data. It cryptographically proves where a piece of content or a command originated. If an agent tries to execute a command on your server, CGPA and SIIF ensure you can verify it is your authorized agent and not a malicious actor's agent trying to bypass your protocols.
It's a brave new world for cybersecurity, that's for sure. But to end our briefing today, I want to look at how these frontier reasoning models are successfully bridging the gap into the physical world and into legacy enterprise environments. Between February 24th and 27th, we saw two massive deployments that prove this technology isn't just theoretical anymore.
First, Alphabet announced that Intrinsic, which was their independent robotics software bet, has officially folded into Google DeepMind.
Right.
Bringing Intrinsic in-house is a massive signal to the industry. It means the autonomous agentic capabilities we've been discussing in software are now being actively mapped onto physical robotics.
And we're already seeing that physical spatial intelligence in action. Google Cloud announced they'd deployed specialized tools for Team USA athletes. They were literally using AI agents to decode and analyze the physical physics of snowboard tricks in the real world.
It's incredible. And on the opposite end of the spectrum, Google Cloud announced a major enterprise partnership with Ab Initio. They're using these new agentic workflows to untangle and parse legacy COBOL mainframe data.
I find that absolutely wild.
Yeah.
We are using cutting-edge 2026 artificial intelligence to read, understand, and modernize banking and telecom code written in the 1970s.
Yeah, it's a huge leap.
It proves that agents can navigate decades-old mainframe architecture just as easily as they navigate a modern web API.
It really does. It consolidates Alphabet's fragmented efforts and shows that whether you're dealing with a physical snowboarder or a 50-year-old database, reasoning agents are the new interface.
Okay, we have covered a massive amount of ground from just one single week in late February. From Nano Banana 2, bringing photorealistic generation speeds to the Galaxy S20 operating apps for you, all the way to the Ironwood TPU hardware backing it up, and the very real security challenges of agentic reconnaissance. Thank you for stepping into the newsroom and diving deep into these sources with us today.
Before we go, I want to leave you with a final thought. This week, Google published a career certificates training video on the fundamentals of AI. That video highlighted the ACT framework for responsible AI deployment. ACT stands for Ask, Check, and Tell.
Ask, check, and tell.
Exactly. We have spent this entire deep dive discussing the pivot to autonomy. So here's the question for you to mull over. If we are rapidly entering an era where AI agents autonomously perform multi-step tasks in the background, whether that's your phone ordering groceries on DoorDash or a developer agent troubleshooting complex telecom networks, how will you fulfill the tell part of that framework?
That is the real challenge. When the AI becomes completely invisible, seamlessly woven into the fabric of your daily workflow, how do you maintain the transparency of disclosing its use to the human beings on the other end of the transaction?
It's a critical question. As the tools get better and faster, the lines between human action and agent action get blurrier.
It's a fascinating space to watch. We hope this briefing gave you the clarity and the context you need to navigate this shift in your own tech stack. Keep exploring, keep questioning how these tools are built, and remember that your next custom deep dive into the world of tech is just around the corner. Catch you next time.